Okay, this video and lesson is on subtracting fractions that are mixed fractions using a common denominator. Now in fourth grade, we can subtract fractions. Sometimes we'll subtract regular fractions. Sometimes we will be subtracting mixed fractions. Before we can even understand to subtract what a mixed fraction is, we have to know what a mixed fraction is. A mixed fraction, or otherwise known as a mixed number, is a combination of one whole and then a part. When we get a mixed fraction, whenever we have an improper fraction, like 7/5. 7/5, my numerator is bigger than my denominator. That means there's a hole in there that we need to get out. And I can convert it to a mixed number. To do that, we subtract or pull out a whole. Now, knowing that my denominator is in fifths, I know that a whole is going to be 5/5. And when I take 7 pieces and I subtract 5 pieces, that leaves me with 2/5. Here is one whole and 2/5. So this is what's known as a mixed fraction. Now we can subtract those. Let's look at some examples. I'm going to begin by placing a mixed fraction on our board and then we'll name it. Let's start with one whole. 5/8. So let's go ahead and write down that fraction. So this is one whole 5/8. Now, there is going to be a lot of different scenarios when subtracting mixed fractions. I'm going to start with the basic. The basic subtraction would be subtracting a fraction from 5/8, like 2/8. Now, before I can begin to subtract, I need to analyze this. I need to look at the fraction that we're going to be pulling from, and I need to look at that numerator. I see I have 5 pieces, and I have to ask myself, just like subtracting with regular fractions, do I have enough there? Can I take 2 from 5? And the answer is yes, we clearly have 5 pieces. I can take 2 away. Let's do that. Let's take away 2/8. When I did that, you can see that my whole is still there. I wasn't subtracting a whole. My whole is still there. Sometimes I see friends forgetting to put that back on in their answers. It's still there. Now we took 2 pieces from 5 pieces, and 5 minus 2 pieces is 3 pieces. And you can see my denominator is still in eighths. That did not change. Just because you're subtracting doesn't change the size of the piece. That was a simple, basic example of subtracting a mixed number where I took 2 pieces from 5 pieces because I had enough there. Let's look at another example. This time, I'm going to build a bit of a bigger mixed number. Let's build a mixed number with 2 wholes. 6/10. So I'm going to begin by writing down the mixed number that we have. Mixed number, we have a combination of wholes and fractional parts. Here I have 2 whole. 1, 2, 3, 4, 5, 6. 6/10. Now this time, we're going to take away 1 whole, 1/10. Now, just like with adding fractions, I like to start with taking away your whole numbers. So let's look. So here I have 2 whole, and I'm taking away 1 whole. Can I take 1 from 2? And the answer to that is yes. So if I take 1 whole away, that's going to leave me with 1 whole still remaining. Now let's look at our fractional part. Here I have 6/10. I only need to take away 1/10. Do I have enough fractional pieces there? There's 6 of them. Do I have enough to take one away? And the answer is yes. So if I take one away, that leaves me with 5/10. And this is our answer. We can simplify this because if you understand that 5 is half of 10, we know that that is equivalent to 1/2. So I could also say that I have 1 1/2 left. Now that was an example again of basic subtraction where we were able to take a piece away because we had enough there. But what happens when you don't have enough there? Let's take a look. So this time I'm going to give you a fraction. Let's start with a simple basic mixed number. Let's start with 1/3. No, I think I'm going to make that 2/4. Okay. So let me write this down. So here we have 1 whole, 2/4. And I want to take away 3/4. Now, sometimes subtracting whole numbers first isn't very helpful. And this is an example of why. Just like when analyzing a regular subtraction problem, we have to analyze this one. I have to analyze my fractional part here. More importantly, I have to look at that numerator. That's what I need to be looking at. And I have to ask myself, okay, I've got 2 pieces there and I need to take away 3. You've got to ask yourself, can I take 3 pieces from 2? And as you look right there, you can clearly see that we do not have enough. I don't have enough pieces there to take away 3, but I need to get some, and we can. Where are we going to get an extra 4th from? Am I just going to plop one down and add one on? No, we're not going to do that. There's another 4th in there. It's in the whole. Here's my whole. So I need to convert this whole into more 4ths. To do that, you have to understand how many 4ths it takes to make 1 whole. So if you understand that, you will know that it takes 4 4ths to equal 1 whole. So let's convert that now. So I'm going to take my whole and I'm going to replace it with 4 4ths. I still have a whole there, but now I've got more 4ths. I still have 1 whole and 2 4ths. It is still there. Let's see what that looks like with our numbers. So my whole that I took here, I converted it into 4ths and I converted it into 4 4ths. Now you can clearly see now how many 4ths I have. I had 2 pieces, but then when I converted my whole into 4 4ths, now I have 4 more pieces. So altogether I have 6 4ths. And as you can see, that's an improper fraction. But sometimes we have to go there when subtracting. We have to get that numerator bigger so that I can take away. Now that I've converted that and I've got my improper fraction, now I am in a position where I can take 3 pieces away. So if I have 6 pieces and I take away 3, here's that 1 more piece I needed. It was in that hole. That clearly shows that I have 3 4ths left. Let's do another example. We'll do another example with models, and then I will do a few examples with just numbers. This time, let's do an example where we have 2 whole. So here is 1 whole, 2 whole, and then let's put a fractional part. Let's put some tenths down. So here I've got a mixed number, and you can see that I have 2 whole, 4 tenths. Now let's say we need to subtract 7/10. Now, I can start with subtracting my whole numbers. I can clearly see that I don't have to take anything away, but sometimes that's not such a good thing. Sometimes we need one of those wholes. Let's look at our fractions to analyze that. So here I've got 7 pieces that I must take away, but as you can see, we've only got 4. Can I take 7 from 4? No, we can't. I need some more tenths. Where are we going to get those tenths? That's right, we're going to get them out of one of these wholes. We need to turn one of these wholes into fractional pieces so that I can therefore go ahead and start subtracting out those 7/10 that I need to. So to do that, I'm going to take this whole and we are going to replace it with 10/10. There's 3, 4, 5, 6, 7, 8, 9, and 10. So there's my 10/10. And as you can see, it equals 1 whole. And I still have 2 whole there. I still have my 4/10 there. I just have to convert one of those wholes into fractional parts. Let's see what that looks like with numbers. So to do this, we took one of our wholes. That left me with 1 whole. And that other whole, we converted it to 10/10. And sometimes you can kind of write it wherever you need to. So now that left me with 1 whole. And now I have 14/10. Now, I think I'm in a position to be able to take away 7 of them. Can I take 7 from 14? And as you can see, we have our improper, but that's okay. Sometimes you have to go there to be able to take away. So yes, I can take 7 from 14. Let's do that now. So here's 4, 5, 6, 7. When I did that, that left me with 7/10 left. So now I can do my math. So now I have 1 whole and I don't have any other wholes to subtract. It's still there. And then 14 pieces minus 7 pieces left me with 7 pieces. And again, the size of my piece did not change. Denominator stays the same. Okay? Let's look at a couple of examples using just numbers and not tiles. All right, let's do a quick number. Let's say I have a fraction 3 4/5 minus 1 2/5. Now, before I begin, I can start with subtracting my whole numbers, but remember, sometimes we have to use one of those wholes. So I'm actually going to hold off on it. Let's analyze our fractional pieces. Can I take 2 pieces from 4 pieces? Do I have enough there? Yes, I do. I have enough there. I can take 4 from 2, and I don't need to come and get any more wholes. So we can just subtract with nothing to do. We don't have to do anything for this one. So 4 pieces take away 2 pieces, leaves me with 2 pieces. Denominator doesn't change. Fifths, they're still the same. Now let's subtract those wholes. 3 whole minus 1 whole is 2 whole. And you can see I didn't have to do any converting, pulling out a whole out of my whole number there. So let's do an example where you do. So let's say I have the whole number, the mixed number, 4 whole and 2 sixths. And say I want to subtract 1 whole 5 sixths. Now, before we start subtracting, let's analyze this. So you have to look at your numerator. Can I take 5 pieces from 2 pieces? And the answer is no, I can't. I don't have enough there. Up here I did because my first number was bigger. Here I don't because my first numerator is smaller. So that means I've got to make that bigger. To do that, I need to take some out of my whole and convert that to a fraction. And I only need 1. So let's imagine if I took 1 whole out of 4 whole, that would leave me with 3 whole. And I would take that whole and I would convert it. And looking at my denominator, it's in sixths. I'm going to convert it to 6/6. And you can kind of see there, you can kind of put a plus sign there if you would like to. You can kind of see how many you have all together now. So now we have 3 whole, and now we have 8/6. And now I'm in a position to take away 1 and 5/6. So let's do that math now. So now that I have a bigger numerator, what's 5 pieces from 8 pieces? Well, that would be 3 pieces. Denominator doesn't change. 3 whole minus 1 whole is 2 whole. And actually, if you kind of look at that 3/6, you could even see that that 3, which is half of 6, is actually equivalent to a half. So we could also say that this is 2 1/2 for this answer. Okay? So to wrap up this learning, when we subtract mixed fractions, our denominator doesn't change. The size doesn't change. We're actually subtracting the numerator, the number of pieces. Sometimes in a situation, you will not have to take from your numerator. I have enough here. So sometimes you don't have to pull out a whole. Sometimes you have enough there, but sometimes, like in this case where we had 2, we had to take away 5. Well, we needed to get more there. I had to pull out a whole, convert it to a fraction, and then I was able to subtract once I got my improper fraction there. So just knowing when to analyze these and knowing what to look for, looking at those numerators. Can I take 2 from 4? Can I take 5 from 2? Yes, I can. And here we could not. So we had to pull out a whole. So looking for those things when you are working with mixed fractions and subtracting.